So as you can glance by the title, the topic is Java libraries you can't afford to miss. And this talk will showcase some of these libraries, some of these projects. And there's a disclaimer. The first one is that all the things that we're going to see today are open source, so you can use them as they are directly on your source code, on your commercial-based projects, anything you want to, as long as you follow the letters of the license. Everybody that's doing open source, just make sure that everybody follows the license, everything is fine. And secondly, we will not be able to cover all the libraries in full detail because we have less than 60 minutes, and trust me, this is going to be a whirlwind tour or stuff that you really would like to make use of on your daily work. My job at the end of the session, hopefully, is that most of you, if not all, feel like this. And you go back with that smile on your face and do the work smiling again, all right? So without any further ado, these are the libraries that we're going to cover today. Some of them you may use already. Some of them might be unknown to you, but trust me, they are pretty good. We're gonna see libraries that can help you writing the production code and other libraries that will help you writing the testing code, okay? So my name is Andres Almiray. I'm from Mexico. I work for this company called Canoe in Switzerland, just because I love the chocolate. My wife loves the cheese. And we do a lot of things with Java and Groovy. I'm a member of the Groovy development team. So if any Groovy developers here in the house? Yeah, a few? No? Really? Come on, guys. It's a really, really good language. Anyway, I'm a Java champion, a Java 1 rockstar, so I think I know a few things about Java, but I definitely know a few things about the libraries that we're going to see today, because we make use of those libraries every single day in our customer projects. So we know when things break and when things actually work. So the challenge that I have for you today is think about writing an application that can consume a REST API. Now, everything that you're going to see today revolves around this example, and there will be other cases. You don't have to deal with REST, or you do persistence, or do some other crazy thing with communications. Some of these libraries will help you. Some others you will have to. We will see what we can do. But again, trying to put everything together in just one particular example. If you need to deal with REST APIs, how would you do that? How would you create an application to do this? We would like to have components that are small, reusable, testable, and definitely we don't want to write boilerplate test code, which means it's the code that you tell your IDE to just generate, right? Source code, don't bother me again until I have to maintain that code. So for this purpose, I chose to use the GitHub API because it's very well known. Almost everybody has encountered GitHub in one way or another. It's very well documented, and in that URL you can see the documentation for version 3 of the current GitHub API. We are only interested for now on the way that you can query repositories, because the GitHub API is huge. We just want to concentrate on one small part. If you query a repository, then that's the URL where you can find the documentation on the payload that you send and the type of payloads that you get as a result. If you send a query to that particular URL with any name matching an organization, then you get a huge result of JSON objects. And depending on how many repositories associated with our organization, you might get paginated results, which will be come into play in just a moment. So this is the type of payload that you get as a result. This is JSON. We have more than 4 or 5 properties. Actually, our repository has around 50 or so properties. We are only interested for now in these 4 or 5 properties. And this will be also, we will see how we can do this happen. Of course, there will be more entries there because that's just on a JSON array. So what we're gonna need in order to build this application. You may already have an idea in your head how to do this. So let's see if we match. Dependency injection. In this time and age, if somebody builds an application, a medium size to big one without dependency injection, I think that's just not a good idea. Let's leave it that way. We definitely need to query HTTP. We need an HTTP client of some sort. We need to follow the REST behavior also in some way. We need to figure out how to do JSON mapping from JSON to Java objects. We want a way to reduce the amount of boilerplate code written by hand, and we definitely need to handle concurrency. All the code is open source and available at that URL. And as a matter of fact, the application that we're going to see today is actually 5 different versions implemented in 5 different ways with different libraries, different iterations. So you can see the benefits and the advantages and the differences between using one another. So I'm going to show the application. And we will need network, and I tested the network. The last time I did this demo didn't work, so hopefully it will work. I'm going to run it. And let's make it a little bigger. Yeah, looks ugly. Well, that's the projector. So I'm going to put the name of organization that doesn't exist. Blah. If I click load, I expect an error. Yeah, network error. Weird, I didn't get a dialog. So let's give it a name of an organization that I know it exists. Pay attention to this number right there. You see it growing? Sadly, you cannot see very well here on the test, the different entries, but they are actually being sorted as we are going through the pages. Anyway, this is a JavaFX application. The only reason why I'm showing you JavaFX is because I love JavaFX, but also because this will force us to, let's make it smaller. This forces us to deal with concurrency. Okay, so remember all the code, open source, available at that URL. So let's start with dependency injection. Basically, what we want to do is you define components that have any kind of contracts. Personally, I like to use interface-based design. So I define most of my contracts using interfaces. And I will inject an implementation, any particular implementation of the interface to another component. So say here we have this particular interface. I have marked as red that type, because that type will come up in just a moment, what this thing is. And I want to inject that particular contract in another component, a controller class, for example. What is in red is the usage of the JSR 330 annotation, add inject, right? Pretty much any dependency injection container these days uses these annotations, and the JSR is quite small. Now, the project that I'm going to showcase to use dependency injection is the reference implementation of the JSR 330. It happens to be Google Juice. Juice, it's quite a smallish project, I would say, in terms of behavior that gives. It's just dependency injection, nothing more. The advantage of Juice is that you can have a programmatic API for defining the bindings. So you define a source type, in this case it was our GitHub interface, and a target type, in this case the GitHub implementation class. We can give it a scope. In this case, I think I gave it a singleton, so I just want one instance of this thing. But if you are working in a web environment, you might have HTTP session scope or conversation scope or some other kind of scope. You actually can write more scopes than this. I have other class, for example, add model. That's both the source type and the target type. If you want a lazily evaluated instance, then you use a provider. If you are familiar with a Spring, this is pretty much a factory bean. It's the same idea. And you can also bind values to constants, for example, a string value or an integer value. This is really cool, and that actually we make use of that feature in the repository to figure out if in production I want to talk to the GitHub API, the actual one, or if in testing I want to talk to a different URL. And that will show you that how it's done. So the advantages, to resume, to put it in summary, the advantage of using Juice is that it's the reference implementation. It's programmatic. It only gives you dependency injection, nothing more. So if you're expecting to see a managed life cycle, for many people know that they can annotate methods with post-construct and pre-destroy. Juice doesn't give you this out of the box. But because it's extensible, you can listen to the life cycle of the instances being created by the dependency injection. There is an extension library using the repository that gives you the capabilities to use post-construct and pre-destroy. As a bonus, if you use Juice, you get access to Google Guava. Guava is quite a mature project. It was started a long time ago to provide new collections that were missing in the standard Java library, to give you new facilities that were missing again in the Java library. Who's using Java 8 already in production? Quite a good number of hands. So you probably are using some functional constructs already. But if you're using JDK 7, you are missing predicates and lambdas or closures or functions, right? So Guava can give you access to these features and optional as well. The API is very close, but not exactly the same. So if you're used to Guava and then switch to Java 8, just be careful. There are some caveats. If, on the other hand, if you, you might not have encountered Juice, but you probably have seen a Spring before. Now, here I'm only talking about Spring Core, the original library that made it happen. Spring has a huge portfolio of projects, but Core gives you dependency injection container, but it also gives you the capabilities for injection values in a test case, creating JMX clients very easily, JDBC template, and I don't know if you know, but the message format coming from the JDK, the standard one, is not thread safe. But the message format provided by Spring Framework Core, it is thread safe. So it has a few additions like that in a few places where it says, you know what, let's make things that are already available in JLS, in the standard JDK, but make it just a totally bit better. So it makes worth using a Spring Framework. So far, so good. If you have any questions, please let me know. I like to have interaction discussions, but if not, don't worry, we can take questions at the end. And if I start to speak too fast, it's because I get very passionate about the topic. Just please let me know. Andres, please slow down a little bit. Okay, reducing boilerplate code. I know that we can pick your favorite IDE and tell it to generate source code using some macro or template mechanism. Everybody knows the Java beans conventions by heart, right? Getters, setters, well-behaved POJOs should have equals and hash code and probably to a string. And we have to know how, when we have a hierarchy of beans to call the super equals or the super hash code, blah, 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 blah. Josh blocks effective Java rules, right? It's a pain to do it by hand. We tell the IDE to generate this code. And IDEs are pretty good at refactoring code. But they're not pretty good when you need to remove a property, right? It's easy to rename, but not to remove. The problem that I see with generator source code is that once it gets generated, it's completely out of date. And now you are the maintainers of the said code that is machine generated. Wouldn't it be better if we were to let the code generation be passed down all the way to the compiler instead? To keep our source code smaller, just give some hints, perhaps make the compiler aware of the conventions that we want. What if the compiler were aware to be of the Java beans convention? Wouldn't that be better? Well, there is a way. It's called Lombok. Lombok hooks into the compiler process, gives hints to the compiler so that it will generate bytecode, the same bytecode, or pretty close to the same bytecode as if you have written the source code yourself. The first class that we're seeing here, this repository class, is the one that we're going to use to map JSON results, remember the repository results from querying the repositories, into a Java object. So that repository class is the Java object we want. So here we are making use of two libraries, Lombok to reduce the boilerplate, and Jackson to map JSON to Java. So here, this annotation, add data, that is Lombok. But just adding add data, you're telling the compiler to generate getters and setters for each matching property, those properties. If you happen to define a final property like private final type name, then there will be only a getter, no setter, and the constructor will take that parameter. If you define more properties with final, then you have the proper constructor. You will also have equals and hash code and a two-string method, all following Josh Block's effective Java rules. And the only thing that you need to do is one annotation. It's just one line of code instead of generating everything and then maintaining it yourself. You might see also, because of how Jackson works, is that for two setters we can override. Besides telling Lombok, I want to generate everything, I also want to tweak some things. Two setters I need to tweak. Why? Because the JSON output uses a snake case convention for the names or the properties, but in Java we like to use camel case. So JSON says full underscore name,
but I want to use full name, so I do a mapping. It looks a bit weird because that's how you only have a small set of values that you can set, or types actually, as annotation values. So this is a hack in order to provide an array of annotations that will be attached to the setter method. We also tell in Jackson to ignore properties that are on map in our class. So remember, the JSON payload may have like 50 properties on the repository. We only care about these 4. So if you evolve your API and add more properties, but at least in the producer side, but if the consumer does not match those properties, just by using that JSON ignore property, you're safe. But if you really want to have a one-to-one mapping, then you still have to change the code, of course. Here's another example. When I show that you can have a hierarchy. There's a base class called application event and another class called throwable event. And the throwable event extends from the first one, and the throwable event can be a data object as well. Oh no, sorry. I'm getting ahead of myself. This is the builder. Who uses the builder pattern? Who likes to use builder pattern? Do you like to write the builder pattern by hand? Yeah, kind of. No. So if you use this annotation, add builder, this will generate this will allow you to have a mutable object, which is the builder itself. And then the real object, in this case the repository, could become an immutable class. We didn't do it because Jackson requires mutable classes. Or at least that is the easy way. That is the easy way. There's another way. I could make it a bit more complicated. I decided to just make it fast. So the other example that I was actually telling you about the hierarchy, the application event, and the throwable event. Well, you can put a data on the child, and you can also add more customizations. When you say, I do want to call the equals and the hash of my parent, or the toString of my parent, besides using my own properties. So because this is final, I will have a constructor that takes one argument, and only one getter, and no setter at all. Isn't this better? Just concise code? Now, you may be wondering, how would the IDE know about the generated code so that I can do things on source code, right? Because it's one thing to say, yeah, annotate that, but I'm going to use that in another class that I'm actually touching. Well, you will need an IDE plugin if you're using Eclipse and IntelliJ, and no plugin if you use NetBeans. Don't worry, it's just one download away. It's very easy to set up. You do need to enable annotation processing because Lombok relies on the annotation processing tool. And you get most of the transformations already out of the box. You can create immutable classes, builder, Pojo, and many other things. Implementing your own transformation is not for the faint of heart, but you don't have to do it. Most of the things that you really would like to do are already provided by Lombok. Now let's look into behavior. And when we are executing the application, we perhaps want to know what's going on. There are many ways to do something like an X-ray into the application. And what is the easiest, fastest way that we developers choose to go when we want to know what's going on? Print line. And then we choose logging. But you were right. So what about logging? Okay, let me get this out of the way immediately. There is no good logging framework in the Java space. None. All of them are bad in some way. But the least worst of all of them is SLF4J. For two reasons. First, if you consume different dependencies that come with different logging dependencies, you can funnel all of them to a single place. That is the SLF4J API. So you only need to configure one place for appenders and logging levels and everything else. The second one is oftentimes we need to figure out if the logging level that we are requesting is enabled. Because if it's not, then constructing the message that is going to be logged might be expensive and is going to be thrown away because the level is not enabled. So we start to sprinkle our code with if level enable, then do the log level, right? Not so good. But if you use variable arguments, you can say log info, the message or the template of the message, and the additional arguments. And internally, the code will do the check. And if the level is enabled, then will construct the real message and then pass it through. If you do not use SLF4J, then the alternative is Log4j2, not Log4j1. Log4j2 gives you almost the same capabilities as SLF4J. It's just that SLF4J is found more times out there in open source projects than Log4j2 at the time being. Okay, moving on. HTTP. How do you guys do HTTP with Java? You build a REST client using a Spring. Yeah, okay, but a Spring is one level up. What is a Spring using for HTTP communication? Apache HTTP client. Okay, does anybody know that Apache HTTP client supports HTTP 2? Does it? Really? I'm not so sure. But how many ways are there also to implement a REST client? I mean, REST is well defined. Why do we need to implement it over and over and over again? So my suggestion is to use another project called OKHTTP, which is a much smaller memory size in memory footprint. It's implemented by this company called Square. You might have heard of them. They make software for Java and Android. So the libraries that they produce are quite small, but very rich in behavior. So here's one example. You create an OKHTTP client, configure a request object. You can supply headers. You can do whatever you want with the request object. Then pass it to the client right there, issue a call, and then you get a response. On the response, you can also query the headers, the status message, the body, which is probably what you're interested in, and then move on. OKHTTP supports HTTP2. It's much smaller in size. You can extend the behavior of HTTP using factories when you create the client itself, and you can listen to changes in the life cycle as well. You can register interceptors, so you can perhaps attach basic authentication or do some kind of header spoofing on the response. Everything's up to you. But HTTP is still too very low level. We are Java developers. We have to deal with Java code. We have to deal with the repository class we created. Wouldn't it be better if we were able to issue a REST call to a particular endpoint and then just receive a collection of repository objects just like that, instead of checking the status code and seeing if we had new pages and dealing with HTTP, right? Wouldn't it be better? Yeah, I think so too. And for that, there is retrofit. So what retrofit allows you to do is this. You, as Java developers, define a contract, how the API should look like in terms of Java code. So for the repositories API, there are two URLs that I can use. One, you supply the name, and this will give me the first page of repositories. In the headers, this is in the documentation of the API, if there's a new page, there will be a header called link that will tell me what is the next page and what is the previous page, and if it is the last or is it the first. You need to pass the headers. When that happens, there's a new URL that you can follow to go to the next page. So we're going to use the second one right there. So that's, if we happen to have new pages, we issue the second call. And notice that what we get as a result is a list or a collection of repository objects themselves, right? Okay. How do we make use of this interface? You create a client, the retrofit client, which is actually a Java Lang Reflect proxy that inside contains an OKHTTP client that knows how to do the magic, so at the end, you only have to deal with the Java interface you define it. That's exactly what we're telling here. We're going to go to that URL. We apply the Jackson converter factory so that we know it will map JSON output to Java using whatever Jackson configuration you may have already defined it. And then we create the client right there with the proxy. And then we just have to use it like that, just plain Java. All the complexity with HTTP completely hidden from you if you are using plain calls. But if you need to handle headers, don't worry, I'm going to show that in just a moment. Isn't this much better than just dealing with plain base HTTP? I think so. So the advantages is that you wrap REST with Java code directly. And it's extensible via factories, and it relies on OKHTTP, which means any code that uses a retrofit is HTTP2 compliant already. how do we deal with multi-threaded code? Remember, we are dealing with a desktop application. Although everything that we're going to see today, you can use it on the server side, on mobile, on the cloud, pretty much the same thing. But in the case of desktop, we have to be aware that everything that you do that is related to the UI must happen inside the UI thread. And everything that is not, such as a network call, a database access, or file access, should be outside of the UI. This is the sole reason why Swing apps never work for consumers, because it's so easy to break this rule and no one enforces the rule. So is there a way for us to tell UI application to automatically run some code in a background thread, and when that computation finishes, then come back inside the UI so we can display the values? Is there a way for us to say this background thread computes but the value and may have some intermediate results, and as they come by, we just publish them to the UI? If you use Swing, there is Swing Worker. But if we want code that is not related to any UI toolkit, then this JavaScript community came up with a solution. They just name it promises. And if you were here a few hours ago when Dimitri was speaking about the completable future, he mentioned JDefer. JDefer is this project that gives you jQuery-style promises in Java. So now there comes back again that promise type that we were showing earlier. So what a promise gives you, those three parameters in the generics mean the following thing. The first type is the return type of the computation. The second type, if there's any error, then you can throw that. And it's not constrained to just throwable or exception. You can throw any type you want to. And if your computation happens to publish intermediate results, that's the third type that you're going to use. In this definition, I said void, but it should have been repository. All right? So we're going to change our API to return a promise instead of just a list of repositories. I'm going to show you how we can produce the promise and then how we're going to consume the promise. Producing the promise means you're going to run a background task. And that right there, inside that lambda, is my background task. That is the network access code. And that code runs on an executable service that is background, which is managed by a defer manager class. Okay? And this whole thing will return me a promise. Now that I have a promise, I can register callbacks on that. This is how I'm going to consume the values. So let's turn into the consumer. Say, for example, you have a controller class. Once you click the button, this will activate this call to GitHub repositories with some parameters, and you get the promise object back immediately. Computation is happening in the background, and if there happen to be any intermediate results, we register a callback. Model get repositories using add, using a method reference. So if there happens to be an intermediate repository, just push it to a list. We'll see how that list handles that values. If there is a failure, network call or parsing or something, then what this code is going to do is simply print out to the stack, to the system error, the stack trace. We could handle that perhaps by popping up a dialog. And regardless of success or failure, what we're going to do is at the end change some state. Because I don't know if you noticed when I was running the application that the load button, the blue button, became disabled while the things were computing. And once they were finished the computation, the blue button became enabled again. That's exactly what I'm doing here. There are a few other callbacks that you can register on a promise. You can compose promises. You can combine them. You can pretty much do the same thing as Dimitri showed with completable future. But personally, I prefer this API much better. So JDefer gives you these capabilities. It is also possible to run JDefer on Android because the release targets JDK 6, so no problems. And this is a one-shot execution. Remember, what you're doing is just running something in a background thread, some background computation, and eventually getting some result. But I said that the GitHub API could paginate results. So we need to continue running and querying, and as we go, perhaps publish those intermediate results. And at some point, perhaps the computation may be so long that we want to finish or cancel immediately. It's possible to do it with JDefer. It's a little bit of a hack, but wouldn't it be better if instead of just a one-shot execution, we would have something like, I don't know, a stream of repositories and almost endless set of values that we can consume? Well, that's exactly what the reactive programming manifesto tells us that we can do, that we can consume values all the time coming from certain data pipeline. So we can think of our REST call as a data pipeline of repository events. Okay? So for that, I'm going to showcase RxJava because it's probably the most well-known project out there, but it's also Project Reactor if you're using a Spring. The type right there, observable, this is RxJava 1. If I change to RxJava 2, the type will be flowable. Why? Because of only one reason. Flowable is the only type that supports back pressure. What does back pressure mean? If the producer is very fast and the consumer is very slow, you got a bottleneck in your system. So if there's no way that we can tell make the producer slow down or make the consumer be faster, then the consumer somehow has to indicate to the producer, wait up, hold on a second, or then maybe there's some buffer here. That is back pressure. There are many ways to do this, but at least the flowable type from RxJava 2 gives you that capability. So basically, this observable object is something on which we can register recipes on how to handle values over time. So what we're seeing here is grab that value, okay, repositories, start an observable, then if we have a limit, we're just gonna read as many elements of that particular limit. But the next thing we also say is, if this operation takes too long, we want to time out for 10 seconds. If it takes 11 seconds, just kill it, I'm not interested. The moment that we start the subscription or listening to events, we want to trigger a change of a state. When we finish, on terminate, it's like the always in the JDefer, whether it was successful or there was an exception, an error down the pipeline, you're going to invoke that thing. We subscribe on a background scheduler. You can create as many schedulers as you want. If we don't do this, then the computation will happen in the same thread as the caller. That will be bad because that will be the UI thread in this case. And once we subscribe, every time that we get an event on a new repository, we're going to add it to the list, and if it happens to be an error, well, we're going to print that out. There are many ways to register these particular callbacks. I decided to go with the easiest one. Is it possible to use retrofit and RxJava together? Yeah, there is a factory for that. So the only thing that you need to do, well, actually you need to do two things. First, you change the API. So instead of returning a call from repository or list of repositories, you return an observable with a response of the list of repositories. Notice that this did not change, it's just the return types. And then you change the proxy builder so that you add the RxJava adapter factory. And that's the only thing that you need to do. Now, we need to consume those observables. If we want to paginate, this is one possible solution. You can abstract the behavior when you have to deal with the first page or the second page. This is nothing related to RxJava. This is plain code for that particular application. So if we want to query the first page, then do this. If we want to query any other page, then we do that. And if we have some links object which knows how to parse the headers, we will figure out if we have to follow the next URL. So how do we do this? Every page that we process will return a list of repositories. But our controller code expects just an observable or repository. So how do we get rid of that list? How do we flat map the list of multiple repositories in just one single observable or stream of repositories? And that's exactly the key. What we're going to do is for every page that we handle, we're going to get a list, and we're going to flat map all those things into a single stream. So there is. Observable supports many operations. Flat map puts all the elements in just one big stream. We're also concatenating the results of one page with the next one. So that's how we're just going to put pretty much not exactly an endless stream of repositories, but all the repositories that are found in that particular organization. So RxJava pretty much implements the observable pattern. If you're familiar with property chain event and property chain listener, it's pretty much the same thing, just with different names and more operations. And it supports back pressure. How are we doing? So far, so good? Okay. Final thing in production is component communication. Sometimes we want to have components that talk to each other, but in such a way that none of them know or have a direct reference to each other. What do we do in this case? Any ideas, suggestions? We use events. And for that, I would suggest to use an event bus. If you use Guava, there is a basic event bus there. There is a better version of that event bus. It's called Ambassador. Ambassador gives you a much better API for defining the producer of events and consumers of events. How are we doing on time? So here is the same controller class that we saw before, but instead of just pushing an exception to the stack trace to the print error, what we're going to do is trigger an event saying, here is an exception. Is there somebody interested in that? Okay, handle that, and I will continue. So here we got an event bus coming from the ambassador, and instead of throwing the exception, we simply publish an event. And by the way, we use it publish as async, which means the controller doesn't care about the listener. It simply says, here it is, deal with it, I'll continue. You could have said also publish synchronously, so the controller will wait for everybody to handle that. How do we produce this? Well, now, how do we consume this? You can register any class with an event bus right here. You remember the post construct and previous story I was telling you about? This is nice about the dependency injection container. They allows you to manage the life cycle very easily. Excuse me. But the important thing is this annotation, add handler for ambassador. When you register an object with event bus, it will inspect all the methods that are annotated with that particular annotation. And the most important aspect of this method is not the name, is the type of the argument. If it matches, if an event gets thrown by the gets sent in the event bus of that particular type, and have registered an instance that matches for that type, then that listener is going to be invoked at the right time when events get pushed by the event bus. There are ways for you to filter if you want to match subclasses or some other kind of mechanism. This is the most easy one. It's very easy to configure with annotations. It's much better than Guava. There is a benchmark proving that Ambassador is much faster, more performant, but the author of the project doesn't work with the project so often now. Is that bad? Only if you found a critical bug. There are not really that many bugs now happening. And it's really stable enough to use it in production. We use it in production. Our customers are financial institutions and banks. We haven't had any problem whatsoever using this in a bank. Trust me. Yeah, seriously, you can trust me with this. And so if you think that you need to use an event bus, this is a sound option. Okay, that ends the portion of production code. We get less than 50 minutes to deal with the testing code. How are we doing so far? Good? Okay? Well, I suppose most of you use JUnit for testing. Anybody here uses TestNG? Ah, a few hands. Interesting. Yeah, I guess for Alexandru Popescu, isn't it? One of the co-creators, co-founders of TestNG. I know TestNG allows you to parameterize tests. Good. JUnit 4 copied that support, but it only allows you to parameterize when you parameterize a method in a test case, and you want to parameterize a second method, it must have the same parameters as the first one. That means the same number of arguments and the same type of arguments, right? So if you need different parameterizations, you end up with multiple test cases. Wouldn't it be a better way to have all these methods that are related to be in the same test case? Yeah, if you use JUnit params. JUnit params allows you to define values directly in the argument right there, or you can define the method name that provides the values, or you can define a class that is the data provider. The class doesn't need to implement any interface whatsoever. So this other test case is parameterized. Notice that now the method takes values, and you must use a specific JUnit runner. So if your test case already requires another runner, you won't be able to use JUnit for RMCM. How many of you follow TDD? Good. How many of you do testing? Great. And I suppose some of you like to use proper TDD techniques. Proper, I mean, you test first and you test just the class on the test. That means that any other collaborator has to be lightweight or fake or stopped or mock. There are many libraries out there that do mocking, but perhaps the best one out there is called Mockito, right? So Mockito is pretty much a testing DSL for mocking values. I like to use static imports, and I should have made this italic because these are a static import from Mockito. So what we're doing here is there's a sample controller class. This is the class under test. We just decided to make it parameterizable just because. And then the model is a real class, but the service is a mock, right? That's the lightweight collaborator. Then what we see here is that we mock that service call right there, say hello with such input, and if that happens, we're going to return with such output. Then we exercise the code, we validate that the controller did the right thing, and we also validate that the stop was invoked only once, and with those arguments and only that method. If any other method was invoked, that would be an error. If more than once, will be an error. If with a different argument, that will be an error. So Mockito is quite good, and it allows you to mock final classes, something that you cannot do with any other mocking. Yes, final classes, they can be mocked. You can have stops. Yes. Oh, yeah. Yes, true. It gives you a warning. You should not be doing this, but it will allow you to mock a final class. It does. Anyway, you can have stops. We only have can results. You can have mocks that are very strict, so you must invoke them in order and in the same number of expectations. Or you can have spies, which are real objects that some of its behavior is fake or is mocked out. If you happen to use JUnit and Mockito and Juice, there is another project that combines the three of them in one place. It's called Yukito. Sounds like wata karate or something like this. Yes, the great thing about Yukito is you can inject properties or collaborators in the test, but you can also have automatic mocks for a particular binding that you do not define. Say, for example, here's again the controller that I inject, and this sample service, I did not define a binding, so this will be automatically mocked by Mockito. And during the setup of my test case, I do the same thing as before, just define the expectation, and then execute the code. This is pretty much the same code, but rearrange it in a different way, right? So it combines the three projects in one place. And so sometimes, maybe, if you are going within integration test and unit test, and you need to inject the same mock, then Yukito will allow you to inject exactly the same mock. You don't have to define it in many places. If you're feeling adventurous, and I know that some people didn't say, I don't like Groovy, but if you want to try Groovy, there is another way that you can do these things in one place called Spock. Spock gives you mocking, Spock gives you parameterization, and Spock gives you shorter, more concise code. Is there something weird about that method name that you see there? What is that over there? That's a string, a real Java string. Isn't that weird that we can use a string as a method name? Also, that I can put spaces. Huh? The JVM supports any character as a method name. Java, the language, does not. Groovy and Spock gives you back that capability. So this is a parameterized test case with inputs and output values, and we have 4 blocks here. The blocks are just regular labels, but in Spock they are important because notice, in the given block, we are setting up our test case, our collaborators, and we're actually mocking a sample service right there and saying, whenever this invocation comes in, I'm going to supply that output. Yes, Groovy has method operator overloading. So that's the right shift operator. So we set up the mock. Then, when actually we execute the stimulus, so that's the actual call. Then, controller model output equals output. What's the type of output? We expect that to be a string, right? Is that the right way to compare strings? In all normalist languages, yes, Java is abnormal. So what Groovy does here again, remember operator overloading, that actually turns out to be an invocation to the equals method of the string. So every time that you wanted to use equals equals on Java, then you can do it in Groovy without any problem and being safe. And is there an assertion there? No, it's not. But that block is an assertion because that's the magic. It is assumed that inside the then block, every sentence that you put there is an implicit assertion. And finally, in the where block is where we specify the parameterization. This is one way to do it. You can also define a data table, and you can supply an iterable, or even a data class that is a data provider, if I'm not mistaken. There are many ways for you to customize this. It's pretty much a Groovy-based DSL. It's not that hard. So who knows Java here? Let's see some hands. Okay, keep your hands raised. Now, rename your .java file to Groovy file, pass it through the Groovy compiler. Now you are Groovy developers. And I'm not kidding, because the Groovy syntax is a superset of the Java syntax, except in 2% of this thing. There is one problem with the array initializers, and now that we have lambdas, we yet don't support the lambda syntax. But other than that, every piece of Java code that you write today is valid in Groovy code. So not only did you learn some libraries today, you are now able to call in a different language. Isn't that great? Huh? Finally, because we're dealing with concurrency in our application, we have a background task happening, and we need to assert at some point that our test case is correct, right? That the background test finished and we got the right results. How do we wait on a test case? What do we use? Fortunately, many people will use thread sleep, isn't it? The problem with thread sleep is if you supply a big timeout, hoping that everything works, your test case waits for the whole timeout. There's no way to interrupt it in between using a condition. But if we were to have a condition, that would be great. And that's why we will use a utility. It's another DSL that gives you this. So we know for a fact that the controller is going to run a background task when it invokes the network call, isn't it? And then immediately, this is another static method from a utility. We say, this is the entry point. We're going to wait a timeout of 2 seconds. So if we wait more than 2 seconds, we kill the test case. There's something wrong. Until some condition, here we're using a method reference to obtain a value, and the condition is using a Hamcrest matcher. You can use anything here also. Notice that it's using the power of method reference, and Hamcrest is quite readable. So if the condition succeeds, the test case continues. Now this waits at most 2 seconds. There is an interval of polling the value that you can configure so that you don't have to wait a long time. And there are many other things that you can do with a utility. Finally, we are testing the GitHub API. And will it be okay if when we run our unit test integration or even functional test that we hit the real GitHub service? No, because we may eventually reach the rate limit if we are not authenticated. If we're authenticated, that's another problem because you're passing secrets and whatnot in the Git repository, blah, 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 blah. Then the next thing will be, let's create a fake server.
and then run it somewhere. Hopefully, it will have the right state when we run our test, right? Wouldn't it be a better way if we could run the server in process? Because I know some people like to also run up a server inside the build tool before the test and then shut down the server. But if you're running the things in the IDE, wouldn't it be better if you just, as we run the test, the server kicks in? Yes, that is what warmock is. Warmock starts as a JUnit rule. You can define the port, you can define configuration for that fake server. Then you define some expectations on the request you may get. If a request with this configuration comes into your server, then we're going to reply with such content. And here we're using a Jane Jackson to transform a list of repository objects into a JSON output. If we get this other URL, then we're going to reply with this. You can also reply with error 500. You can reply with a delay. There are many ways to do this. And I'm going to showcase that running live. I'm going to do a clean and then test. And this will run integration test, functional test, and unit test. And of course, no hands on the keyboard. And you will see a screen popping up in just a moment. And sadly, it doesn't look that good. But those things, everything were coming from a real server that was defined using warmock. So that's basically what I want to say about warmock. It's pretty good, pretty handy. Remember, everything that we saw today is open source. If you can find a way to help open source, thank you very much. The easiest way to help open source is you're using one of these libraries or some other open source code. You find a problem, report it. Please give enough information about the environment, the steps. That is plenty. If you can supply a test case or if you can supply a patch, much better. But just at the very least, let the other people know that there is a problem with the software that you were using. Some of you may be wondering, but what about library X, my favorite library? I didn't see in this list. Oh, shame on you. Well, there are some other libraries, actually. I'm pretty much out of time. We're not going to cover them. Dagger 2 is an alternative for doing dependency injection that provides compile time binding. If you want to have compile type safety, then go with Dagger 2. Snake YAML. YAML is another format. It's a superset of JSON. So Snake YAML allows you to consume YAML very easily. Message pack is like JSON, but it's a little bit binary. It's more compressed. And you can use message pack to talk. Sorry, need to drink something. Wow, my voice is gone. See, I get very excited about these things. As I was saying, message pack. You can use it for Java serialization, but you can also use it with JavaScript and Objective-C and Swift and whatnot, because message pack has supports more than 40 different languages. And it's quite small, it's quite effective, it's quite fast. It's probably the fastest serialization mechanism that you can use across heterogeneous systems. You can use CryoNet. If you're using Java, this is the fastest solution, much faster than, well, everything is faster than Java serialization, but Cryo is the one that wins over everybody. You can use gRPC for communicating different clients and servers, or you can use ZeroMQ if you want to be one level down, so almost at the socket level, or you can use Netty if you want to. If you happen, I have just noticed that I missed one of them there. If you happen to have a web app and you want to test it out using a fake client or a simple client, don't use OKHTTP, use REST Assure, which gives you a testing DSL for defining the expectations. And if you need to test out the real server, then you probably want to do a container-based testing, and that's where I will be missing. The one that is missing over there is Arquillian. All right, with that, mulțumesc. Thank you very much.